Hello, my name is Gert De Laet and I'm the Director of Program Management here at Oracle Academy. Today I'm going to give you a brief but practical introduction to machine learning. Coming out of this presentation, I am hoping that you are able to understand what is machine learning, what is the value of machine learning, how to implement machine learning, and the required machine learning features and techniques that will allow you to accomplish practical tasks. So the agenda for today is as I will start with a brief introduction to machine learning and the where and why of its uses. I will then go into the practical part of the presentation and talk about how you can start working on machine language. In that part, I will also go over some features and techniques of machine learning and finally a short summary of my presentation. So let's jump right into it. What is machine? The term machine learning was the first coined or invented by Arthur Samuel in 1959. He defined machine learning as the field of study that gives computers the ability to learn without being explicitly programmed. So at the time, he was working on a checkers playing program that you can see on the display here that is regarded today as one of the first successful self-learning programs. And actually since that time, many have argued that his definition is too broad or not accurate enough to define machine learning, but for our purposes, I think it suits our needs perfectly. So let's look at the keywords in his definition. We're all familiar with programming. The computer is giving a set of commands, so there are very limited possible data inputs and even less potential outcomes. A classic example on the display that you can see here is a if-then-else structure. So if we have a certain condition, for example, if you score above 50, then it's a pass. Otherwise, the else, it's a fail. This programming is explicit. Everything is well understood in the inputs and the outputs. We know that the score can only be between 0 and 100, and the outputs are either pass or fail. So for machine, it looks at the world at a complete different angle. Unlike explicit programs, the inputs and potential outputs for machine learning algorithms are considered almost limitless. Machine learning takes in a lot of input data. In fact, the more data points available to it, the more intelligent it can be. And that is why big data and machine learning are considered inseparable. This is why, although in the 50s, the 1950s actually gave birth to artificial intelligence and machine learning, it's only now that it's starting to become part of our everyday life, because today we are collecting and have access to more data than we could have ever imagined in the past. So a good machine learning algorithm will analyze all of this input data, and from it will make predictions. And actually from these predictions, it can then create hypotheses, which it can then test to see whether they are valid or invalid. From the result of the hypothesis testing, it will try to describe or understand a certain behavior. And this becomes a rule or a learning that it can pass back into its algorithm to improve future predictions. And this is very similar to the way humans actually learn. In some machine learning worlds, we see these actions defined as ingest, predict, monitor, and train. So now that we know the fundamentals, the very basics of machine learning, where and why would we use it? So where would we use machine? I think, honestly, the question is more, where can we not benefit from machine learning? We are already seeing machine learning algorithms built into personal assistants such as Siri, our mapping applications, which provide intelligent paths from point A to point B, and even in our pizza order and delivery systems. So the thing that you see in the middle is called a DRU. So it's Domino Pizza's Autonomous Pizza Delivery Vehicle, or Domino's Robotic Unit, the DRU acronym. So machine learning is becoming more prevalent in cybersecurity, more in healthcare, in financial services, sport, and even in law. So I want to take one example of healthcare where machine learning is used very frequently. Can we use data to help, for instance, prevent heart disease that could lead to heart attacks or strokes? It turns out a simple tool like a data visualization tool combined with machine learning, with a machine learning plugin, might be the keys to the solution. Machine learning algorithms are applied on a patient health data to predict the prospect of heart disease. The process can be summarized as follows. So get data of patients known to have heart disease. This data set contains information related to the heart disease like blood sugar, cholesterol, and other medical information about the individual. Then create a model using that data and use that model to predict the heart disease likelihood in other individuals for whom we know their medical history or medical information. So by using these methods, even in a simple to use data visualization tool, it can help answer complex questions. What does this mean for you and jobs in the future? This means that most jobs will come into some kind of contact with machine learning. So you will either be working in machine learning, it is coding for instance, or you will be working on machine learning, it is maintaining systems, is maintaining robots, or you will be working with machine learning. For instance, a lawyer will have machines investigate precedents or prior cases to make suggestions, or will be working for machine learning. Some argue that machine learning and artificial intelligence can provide the service of middle management for, say, a call center. It can monitor call times, customer satisfaction scores, and other metrics to determine changes in business processes for people working in the call center. So this screenshot is of an actual job that is available at the moment. While the salary is huge, but as you can see, the skills required are actually quite significant. As with most machine learning jobs, you will not only have to be an expert programmer with experience in machine learning, but it's very likely that you will need skills in another industry. In this case, financial services and trading skills. So before moving into the implementation of machine learning, here I want to present you with a real-world example. Predict bike sharing needs using machine learning. I will refer to this case study during the presentation. So as you all know, bicycles are quickly becoming popular for commuters in some areas. Many cities offer some type of a casual bike rental or a bike sharing program that's easy to use either with a swipe of your credit card or with a click on an application. So while it is quite a convenience for city residents, the companies actually supplying the bikes have a more complex problem. So how to predict the needs of the customer and make sure that there are enough bikes in any given location. The proposed system was a multi-agent system. These type of systems have previously been employed in similar tasks like taxi fleet coordination, where they offer an ideal solution to abstract away issues of the different existing platforms and communication protocols. Bike data sharing agents, as you can see on the top corner, are responsible for obtaining data about station information and about trip information. The weather and environment data agent obtain the weather data requested by the processor agent. They provide historical weather data for the requested dates and location, which will later be merged with trip or station data. The weather data obtained by this agent is daily data on minimum, maximum and average temperature, wind speed, rain, and minimum and maximum pressure. The geographic information data agent obtains the geographic location and the distance between stations, as well as the altitude of each station. So, how can you now machine learning? Now imagine that it is your job to implement machine learning, big data analytics, artificial intelligence technologies needed into the business environment. You are going to need to know where to begin, what kind of problems to expect, and how the specific related projects and services differ from what you are used to. I will briefly touch on processes and steps to implement machine learning, existing tools, and provide you with some great example implementations. Now imagine that implementing machine learning into the business environment is going to become your situation in the near future. While there is a surplus of theory around business applications for data analytics, there is a significant lack of practical real-life experience to draw on. This is largely due to the fact that adoption of these new technologies for many industries is new, and the results of pilots are just coming to light now. So the actual process of creating a predictive or a recommendation project consists of several stages or steps, as you can see on the slide. The first and very important stage is determining the objectives and constraints used in the modeling process. So for each objective, there should be chosen a metric, and the model should be trained specifically for it. Its success will be determined in terms of this specific metric, and therefore choosing the right metric is a critical factor of success. In our scenario, it will be an efficient bike service. The next step is the assessment of available data sources, estimation of available data volume and composition. An important difference between machine learning technologies from the more conventional ways of data analysis is that the most valuable data is raw data, without aggregation and pre-processing. So, for the modeling, it is preferable to have a larger amount of data even when inconsistent and containing error and omission, rather than a small amount of clean data. So, what that means is if the data is not enough, at this stage, you can define which data will help solving the task and start collecting it separately. Training the model, in contrast to conventional software development, does not require pre-development of rules and algorithms. Data analysts determine the range of factors that may affect the process being modeled, and this is very often an extensive process to ensure important factors aren't missed. At this stage, we need the experts who know the subject area and the process being modeled to cooperate with the analyst to train the model and possesses the necessary tool. So it's a collaboration between two. Unfortunately, the quality of the model can be estimated only after its training and testing are ended. For many tasks, it's advisable to combine determined formulas reflecting the known properties of the process with the refining models that are based on machine learning technologies. So, after model training, it is integrated finally into the client's management system. This integration is simplified by the fact that the model realizes only one function: it predicts or recommends. In this regard, the interface is very simple and the integration is reduced to data transfer and displaying those recommendations. Practical tests are carried out with client-side experts participating, and during testing, it is necessary to measure the accuracy of the model and achieved economic effects. The last step is the production use of the service that successfully passed testing. The production use requires constant monitoring of the model quality and its regular additional training on newly collected data. In the next several slides, I will go in more detail on some components from the different steps listed here in the diagram. There are two main languages to demonstrate machine learning. And personally, I would recommend either one of those depending on your needs, since they represent more or less 75% market share. Of course, other languages are available to use, but these two languages, R and Python, provide the best resources and capabilities for studying and working with machine learning examples. Both languages share some positive points. As open source tools, both R and Python are free to download for everyone, in comparison to some other statistical commercial software tools. Many new developments in statistics appear first in the open source packages of R or Python, even before making their way to commercial platforms. And while many commercial software tools offer customer support, often paid, R and Python dispose of online communities that offer support to their respective users. And then lastly, according to O'Reilly's Data Science Salary Survey, data scientists that use primarily open source tools like R or Python earn a higher median salary than those using proprietary tools. And in addition, industry uses these two languages the most as well. So getting with machine learning, when you start delving into either R or Python, you might find that you absolutely cannot go on without some additional information. Fortunately, the R and Python community is prepared to help you in all sorts of ways. You may want to visit these sites listed on the slide here if you learn best simply by reading material. Some people learn better with tutorials. You can find many tutorials of various types online as well. Another way to work with R or Python is to view videos. More and more people are turning to videos as a means of learning, especially for new technologies, without actually reading anything or participating in a tutorial environment. Seeing someone else perform the task does have advantages in that you can focus on the technique rather than how to implement it. Coding in Python is very similar to any other programming language. Also, machine learning involves working with data of various sorts, but much of the work involves numbers. In addition, you use logical values to make decisions about the data you use. For example, you might need to know whether two values are equal or one value is greater than another value. Python and R support different number and logic value types. Of all the data types, strings are the most easily understood by humans and not understood at all by computers. A string is simply a grouping of characters that you place without double quotation mark, very similar to another programming language. And no one wants to keep repeating the same task as it becomes monotonous and boring. When you create functions, for instance, you define a package of code that you can use over and over to perform the same task. This is just a high-level view on some of the functions that are available for coding R and Python. To create viable sources of big data for specific needs, you might find that you actually need to create a new data source. Developers build existing data sources around the needs of the client-server architecture in many cases, and these sources may not work well for machine learning scenarios because they lack the required depth, meaning so being optimized to save space on hard drives does have disadvantages. In addition, as you become more adept in using machine learning, you find that you can ask questions that standard corporate databases cannot answer. With this in mind, the following section describes some interesting new sources for big data. Governments, universities, non-profit organizations, and other entities in general often maintain publicly available databases that you can use alone or combined with other databases to create big data for machine learning. You can obtain data from private organizations also, such as Amazon and Google, both of which maintain immense databases that contain all sorts of useful information. In this case, you should expect to pay for access to the data, especially when used in a commercial setting. You may not be allowed to download the data to your decisions, such as where to put new stores, for instance, or new factories, and use the data from those private sources. You also need to test the algorithm to determine whether the training of your algorithm is a success. Everything in machine learning revolves around algorithms. An algorithm is a procedure or formula used to solve a problem. The problem domain affects the kind of algorithm needed to solve some sort of problem. For instance, driving a car, or for instance, playing dominoes. As we have seen in the beginning of the presentation, many people are somewhat used to the idea that applications start with a function, accept data as input, and then provide a result. So machine learning turns this process around. You know that you have inputs, and you also know the desired result. However, you don't know what functions to apply to create the desired result. So training provides a learner algorithm with all sorts of examples of the desired inputs and results expected from those inputs. The learner then uses this input to create a function. In other words, training is the process whereby the learner algorithm maps a flexible function to the data. The output is typically the probability of a certain class. To our case study, we know the proposed system was a multi-agent system. The system is divided into a group of agents, so you will find bike, weather data collector agents, geographic information agent, data persistence agent, demand prediction agents, and API agents, for instance. Several multi-agent platforms were evaluated for this solution, and this one in particular is implemented in Python. I will discuss this in more detail in the implementation section of machine learning later on, how this is done. We can now see that there is a combination used of existing data sets and new data sources. New data sources are built using the bike data sharing agent, who is responsible for obtaining data, for instance, collecting data as station information and trip information. Weather and environment data agent obtain the weather data, and the geographic information data agent obtain the geographic location from existing data sources. And different regression algorithms and training models have also been employed in the process of bike demand prediction. As a side note, the map shows self-service automated bike sharing services that offer transportation, let's say, from point A to B, and you can click on a city name on the list on the map for more specific information, whether it's in operation, whether it's planned or on the construction, etc. So what other techniques and functionality are important? Some basic operations, again, very much in line with a regular language. If you want to implement existing machine learning algorithms, let's say you want to do it from scratch, or you need to devise new ones, you require a profound knowledge of probability, linear algebra, linear programming, etc. You also need to know how to translate math into working code, which means having sophisticated computing skills. So if you want to apply existing machine learning for practical purposes instead, you can leverage existing R or Python software libraries using a basic knowledge of math and statistics, because they have that knowledge already built in. In the end, you cannot avoid having some of these skills because machine learning has strong roots in both mathematics, and statistics. Having examples, the form of data sets, and a machine learning algorithm at hand doesn't assure you that solving a learning problem is possible or that the results will provide the solution. So in a perfect world, you could perform a test on data that your machine learning algorithm has never learned from before. However, waiting for fresh data isn't always feasible in terms of time and costs. As a first simple remedy, you can randomly split your data into training and test sets. The common split is from 25 to 30% for testing and the remaining 75 to 70% for training. You split your data consisting of your response and features at the same time, keeping correspondence between each response and its feature. So preparing data and rating data consists of several steps. Obtaining meaningful data, also called ground truth, acquire enough data for the learner algorithm to work correctly, guarantee the gathered data into a matrix, deal with bad data, such as missing cases, etc. So that's really part of your preparation for data and the rating data functionality. For instance, a built-in function available in R, Python, or Java is called Plotly. It's a great graphic library with visualization features to make interactive publication quality graphs online. Examples are line plots, as you might know, scattered plots, area charts, bar charts, etc. Heat maps. So a lot that's built into that great graphing library called Plotly. So applying what we have seen just now, a real-world example. So from the central station to the station in the north, we see most traffic. You see that color-coded in red or it's violet. The visualizers offer access to historical data as well as demand prediction services. The web application, on the other hand, will be compounded by two main sections. Historical data visualizations offer all the visualization of trip data information and permitting the user that is filtering historical data to explore user behavior between stations. Forecasting and status will show the current status of the system and the demand forecast of the selected stations. Of course, you can't test out these features for yourself unless you can get your hands on it. So to learn more about machine learning, you can download the Oracle Data Visualization Desktop. So it's a downloadable version of the Oracle database visualization. And you can see how much you love it. The Oracle Data Visualization Desktop has all the features and components we described earlier, and they are all built in. And as a user, you can develop your own custom Python or custom R scripts that can perform predictions, and you can upload it into the Oracle Data Visualization Desktop. Uploaded scripts can then be invoked from data flows, and in case you are interested, there is also a short video on our website. So in summary, the Oracle Data Visualization portfolio is making it easier and even more convenient for you to analyze data at any time, anywhere, even offline, and start getting familiar more with scripting and with machine learning in general. So with that, I sincerely hope that coming out of this presentation, a simple and basic understanding on what is machine learning, what is the value and importance of machine learning in the future, how to implement machine learning, and the required machine learning features and techniques that will allow you to accomplish practical tasks. So thank you, and we hope to see you again soon.